Math. The way space speaks to us, and the way we interpret space. Trigonometrically, here's where it gets interesting. How do we find the impossible to see? How do we even know if it's there? Have you ever truly wondered what a black hole is? How in the world would we know where they are if they're black in the middle of space? Is time travel possible through these black holes? What kind of power would be generated if it were? All of these questions can be speculated and answered by way of math. From the center of a circle to the outer edge, we have the radius. When this radius rotates 360 degrees, that is called a period. Say we have two different objects rotating around the outer edge. Both of these objects rotate around the center, or the vertex. As we can see, if we place a two-dimensional grid on top of the circle, we can calculate the angles of multiple objects rotating around it. We do this using sine and cosine. We can also find the center of the circle, or the black hole. We can place a grid into space using numerous circles to map the stars. Each star rotates about a certain point or the center, or the black hole. Using variations of algebra, we can calculate the size of the matter circling about the black hole. Most black holes lie at the center of the galaxy and are massive in size. As we can see on this comparison chart, some black holes are roughly 2 billion times the size of our own sun. If we think about the gravitational force of the sun and multiply that by 2 billion, we can't even imagine that type of power. It's enough to capture light so that it can't escape. That's why we can't see them, and that's why they are called black holes. Math has always eventually solved the mysteries of man. For centuries, the great question was, can man fly? A famous mathematician, Lord Kelvin, once said that we'll never be able to fly unless it's in a balloon. He saw the Wright brothers come out with their first model planes before his death in 1907. Using a simple equation of pressure equals velocity, we can now transport anything to anywhere using planes. Once again, placing a grid on a black hole, we see the spiraling motion. This is known as a wormhole, and this is where the idea of time travel comes from. We discussed that black holes capture light, meaning that light particles have weight or matter and can be moved from one place to another and split. Looking at this mathematical grid, we're able to see that. This means that the same matter is in two different places at once. Or if we substitute our bodies in for light, we would be in two different places at the same time. There are still many explanations that math has yet to give us, but one day it will.